So now, here we have 3 resistors. That's 1,000 ohms with 5 volts across it, thanks to the regulator. That's 1,000 ohms with 10 volts across it. There you can see it's a lot hotter. And then we have a 2,200 ohm resistor with about 10 volts across it, right there. And again, it's warmer than the 1K with 5 volts across it, but not as warm as the 1K with 10 volts across it. So we're using a voltage regulator. That was that other little heat source right there, to keep 5 volts across the 1K resistor, giving us about 0.025 watts at 5 milliamps of current. Now, the 2,200 ohm resistor also has about 5 milliamps of current approximately, but twice the voltage right there. So we got about twice the wattage. Again, a 2K resistor, those numbers would add up, but here we're close. But with the 1K resistor, we got twice the current, but twice the voltage, and pretty close to 4 times the wattage. So now in the last short, we saw that this 1K resistor with 5 volts across it, not very warm, but 1K resistor with 10 volts across it, quite warm, and then 10 volts across the 2.2K resistor, somewhere in the middle. So we're using a voltage regulator to set 5 volts across that 1K resistor, about 5 milliamps current, 0.025 watts, pretty straightforward. We got the same amount of current, basically, with a 2,000 ohm resistor right there, but it's twice the voltage, so it's going to be about twice the wattage. And so a little bit more resistance, so we're a little bit lower on those numbers. But in any case, with the same resistance that we had over there, but twice the voltage right there, we get twice the current. But again, it's twice the voltage right there. So it's 4 times the wattage. This resistor is going to get 4 times as hot, even though it's only passing twice as much current as this one. And it's all because of how much voltage is across it. Heat goes up really quickly. So now, in the last short, I wanted 10 volts across a couple resistors, but 5 volts across that resistor. So I used a 7800 series integrated circuit. It's in the TO220 package right there. 0.5 means 5 volts. So that's 5 volts out in relationship to the voltage you set at the ground pin, which we set 0 volts right there. So we got 5 volts out. Now that extra voltage gets converted to waste heat, but you need at least 2.5 volts for these integrated circuits, higher than what you're outputting. So in any case, we got left pin 1, middle pin 2, and then right pin 3. Be aware though, the heat sink tab right there is connected to that middle pin ground, a direct connection. And so in any case, input, ground, output right there. So that's pretty much it. Usually there's capacitors added to the input and output going to ground, but we don't need it in this case. So it would just be extra stuff to have to explain.